Thanks, Pat. Yeah, the wildfire workshops are, we do these worldwide. They're no cost, and they're publicly accessible, and they're about anywhere from 1 hour to half a day, depending on which workshop you're attending. And we have our SMEs, like folks like us on the call, as well as our peers on the ATG group. We'll just sit there for half a day with you and go through the basics. And then we get from basic to intermediate to advanced level topics. And you'll know at least about 60% of what you need to know in just that half a day session. So they're very valuable to get up to speed on this technology and the platform. Okay, so there's a question here from the chat window. It's really about the ecosystem availability of tooling on the Linux on Z platform, right? So here's the thing with all of these, with different architectures, right? And it's happening right now with Apple M1 too. This is not unique to the IBM Z architecture, right? So today, developers have easiest access to commodity hardware, right? They can go literally anywhere. It's a laptop is x86 in most cases, right? M1's changing that. They can go to most public cloud vendors. They get an x86 based architecture. And it tends to be relatively cheap, right? You can buy a $400 laptop and do development on that. And that's why a lot of the open source tools that you see out there and ISV tools, they tend to start off on that, right? Which is smart because, you want to get maximum reach, and because there's so many Intel cores out there, you want to build for that platform. So usually the other architectures, including, the S390X architecture like ours, Apple's M1, PowerPC, PPCLE, right? All of these architectures do have to invest a bit in terms of catching up to that ecosystem, but that's also a curated list, right? Because there's millions of things out there. I mean, you go to GitHub right now, there's millions of open source projects out there, right? It is not worth anyone's time porting all those millions because not all of them are important, right? So whenever we have gaps available, I'll give you an example, right? In 2014, Kubernetes was not available on the platform, okay? And we all wouldn't have been here if we didn't make it available after, but in 2014 it wasn't. And we had requests coming in. One request kind of helps, but it's not enough to justify the investment into that because, we need developers, we need testing, we need people to upstream it and send PRs. But then we had a lot of requests coming in for it. And then that's how we decided, all right, we need to invest in Docker, we need to invest in Kubernetes and the container ecosystem. And then the list goes on. And now we have 300-400 of these really important open source tools in the platform, right? So if there's a tool or a library that you would like to use but isn't available, just reach out to us, right? We have an ecosystem team. There's one in Toronto, there's partially in India, there's partially few in Germany. We can port it for you. And the quickest turnaround time I've seen is a couple of hours. We just send in a patch, like here, put this build instruction in the makefile and you're good to go. It just works, right? So, yeah, and I can see Vic nodding his head here. Right? He's done this before too, many times, right? All of us have.
My favorite anecdote with this is I'm probably a bit of a cowboy when it comes to the stuff that I run on some of the systems that I've got access to. If anyone's familiar with Gentoo Linux as a distribution, you'd know that it's a build from source distribution. So everything that you run on a Gentoo Linux box, you've built the source code yourself. And I run a lot of Gentoo on S390X. And with the exception of one particular package, which I won't name because it's not fair, the only reason that it wouldn't run is because it actually had inline x86 assembler code in it. So it was designed for x86 and I just used something else as an alternative. So the majority of open source code out there is built using things like the auto tools, right? And they figure it all out. They figure out what the size of an integer is, and they figure out whether it's big or little endian and do the right stuff. So the majority of open source code out there, as Elton says, sometimes it's just a matter of, here, add this extra architecture into your makefile, and away you go. And, there's often very, very little code change that's actually needed to make it run. And, I'm sure you've all heard, Linux is Linux is Linux. And this is the point where that really rings true, is because a lot of the code out there, really simple to port.
Yep. Thanks, Vic. And like I said, right, we have an ecosystem team that's staffed just to do this kind of stuff. So whether it's open source upstream, GitHub links, or ISV technology that isn't open source, right, proprietary stuff, do reach out to us, because we don't know that these things are important until we hear from you, right? Because everything we do is based on client demand. And if there's no client demand coming in through emails or, just like whatever mechanism, right, we just don't know it's that important, right? So just do reach out to us, right? All right, so the next question now, we're going to jump into client-specific use cases here per geo, okay? So we have one person here in each geo. They're going to represent all of their clients out there. So we're going to start with Europe. So this is a question for Willy. Is there, one or two interesting use cases that you can mention in terms of the data that they were trying to access, the programming languages, the benefits of the platform? Are there one or two examples in terms of the European region that you would like to describe here?
Yes, Elton. So I probably need to sort out a little bit what which one we want to talk about. But I think let's talk about the use case of this client. And basically, this one client, they developed some applications by themselves and started building a solution. And typically you start developing on commodity hardware and on your PC, on Intel and so on. But then they saw that it needs much more development that they think or that they thought of. So they hired external freelancers and programmers and started building some public cloud development servers. And then they started putting together what they needed to put together. And guess what? Their logic was to build these services scalable, but the point was it was unpredictable what they need. So how much they scale or how much they need. And then COVID came. So it was, it hit the point where COVID jumped in such area, in some areas, that these services needed to be 10 times, 20 times faster or more in capacity to answer to their requests. So they were having trouble to even, get that hardware so fast in the system, get the software set up, get them in the network, get them in the security, all that. So they urgently came to IBM and said, don't you have a better idea? So we said, you know what? Sure. This application is in Java. So basically that was a very easy task in that case, because Java runs everywhere. So that's why we said, why don't you put it on Z, and we're scaling vertically. And that was the joker here. It is not about adding hardware, adding, the software and adding it in secure. You scale vertically. That means if my servers or my nodes in that case for OpenShift, need more capacity, I can do that dynamically. I can do that on demand. I can do it on demand for memory. I can do it on demand for network. I can do it on demand for capacity. And that's where they grow vertically and could scale up very quickly. And because it was in Java, that was a very perfect, or was a perfect fit for these guys. So in parallel, I can tell this is one of the areas that is very highly appreciated. It's basically inheriting the security that I meant at the beginning with the scalability, with virtual scalability, or even, three-dimensional scalability. If you want to scale out on a second server or on a second site. Mm-hmm. And we had a customer that needed to scale in Europe and then in US. So they had the same application. Say, how can I do that? Well, that's easy if you have an environment on Z, and therefore it was a perfect fit. And just in two sentences, the second perfect fit is if you want to unify the tools for development, deployment, and operation. So OpenShift is the Kubernetes